Alright, path of the ball kicked from the ground can be modeled by this function. How long does it take? How long, meaning they're asking for a time for the ball to reach the ground. So if we just think about what's going on here, ball starts on the ground, it increases to a certain point until it hits that vertex, and then it starts to decrease, and eventually it's going to hit the ground. So what we want to know is this point right here, when it hits the ground. So in this particular context, that's an x-intercept. So we need to find the two x-intercepts and then find, identify which one makes the most sense for when it hits the ground after going through the air. So in order to find these x-intercepts, we want to plug in 0 for y, or in this case f of t. So I'm going to get 0 equals negative 16t squared plus 80t. And then from here, it's just like solving one of these things, any one of these. We've got it set equal to 0, so that's number 1. Number 2, we're going to look for a greatest common factor. In this particular case, 8t is actually the greatest common factor. And if we factor out that 8t, then it leaves me with negative 2t plus 10. And that's equal to 0. From here, we've got zero product property. So I know 8 equals 0 doesn't make any sense. T equals 0 is actually going to be one of my solutions, and that's going to be this solution right here. This thing starts off the ground, so at a time of 0, it's getting lift off the ground. And then my last solution is going to come from this expression right here being equal to 0. So go through and solve. We get negative 2t equals a negative 10. Divide by negative 2, and you get t equals negative 10 divided by negative 2 is positive 5. So in other words, to answer this question, it takes 5 seconds for the ball to come down.